Yes, observatory fans. It's a nunchuck moment. These are wooden. Stream of light from the sun. Absolute. Say good morning to your son, because there it is. 8 minutes and 20 seconds? I don't think so. Follow me. This is pre-question 3 material. The question is going to be, if the sun suddenly turned on, how long does it take to get here? Well, they say 8:20, but each telescope, what do they see through their lens? Now, there are 2 equations for this exercise. If you need to pay attention, if you lose where you're at and you start to lose track, go back and start from the beginning, because this is a perler, okay? Especially with the gem that we found. It's 2 equations for this. You need to know these like the back of your hand. The distance between Earth and the Sun is 150 million kilometers. If we divide that 150 million kilometers by the Sun's diameter, 1,390,000 kilometers, we get 108 suns. The measurements for this exercise for the distance between the Sun and us is 108 sun diameters, right? Box that, but keep it close. Sun's diameter again, 1,390,000 kilometers. That's what they tell us, okay? Our diameter is 12,742 kilometers. If we divide that by that, we get 109 Earth. So for the rest of this exercise, the diameter of planet Earth is going to be 109 Earths into the Sun's diameter. That is going to be our size, our measurement. Now, anyone spot the absolute magic that we've got on that board? It doesn't matter what size sun you use. To get a working diagram going that saves the scale, you get the sun and you multiply it by 108, because there are 108 of each sun diameter in between the Sun and Earth. I've used 1.39 centimeters for the smallest one we're going to work with. Not work with, we talk about it once. The reason for that is the Sun's diameter is 1,390,000. We're going to start at 1 centimeter and 39. Let's go. Any sun, you multiply it by 108, and that gives you the distance. You then divide that sun by 109, and that gives you Earth's diameter in the equation. Are we ready? Alexa, what is 1.39 centimeters multiplied by 108?
From onlinecalculator.org, 1.08 meters equals 108 centimeters.
Alexa, what's 1.39 centimeters multiplied by 108?
1.39 centimeters times 108 is 1.5012 meters.
Right? If the sun has a diameter of 1.39 centimeters, the distance between the sun and the Earth would be 1.5 meters. We get the 1.5 meters by multiplying 108, right? Because there are 108 suns in between the sun and Earth. Alexa, what is 1.39 centimeters divided by 109?
1.39 centimeters divided by 109 is approximately 0.1275 millimeters.
Do we get that? If the sun had a diameter of 1.39 centimeters, right? If we divide it by 109, because there are 109 Earths in that diameter, Earth's diameter is 0.127 millimeters. That is 127 micrometers. There are 1,000 micrometers in a millimeter. Watch this. So we're looking at about 1/8 of a millimeter, right? Earth is in there. It's a tiny speck, right? You can't see it. You can't see it. Can't see it. But the question is, if you were on this tiny 127 micrometer size Earth, would you see the sun shining if it was 1.5 meters away and it had a diameter of 1.39 centimeters? Of course you would. This, by the way, is to scale, right? No, actually, should probably be about there. That is 1.5 meters. This is the only line that's going to be to scale. That is to scale. Know what that means? It's to scale, right? We're going to miss this one. We're going to jump to the next one. If the sun had a diameter of 13.9 centimeters, so we've multiplied it by 10. Multiplied by 10 all the way up, right? This is to scale. 13.9 centimeters. That sun is to scale. The distance would be 15 meters. Alexa, what's 13.9 centimeters multiplied by 108?
13.9 centimeters times 108 is 15.012 meters.
Right? All the time. We are staying in proportion. Right? I'll do this one more time as well. Alexa, what's 13.9 centimeters divided by 109?
13.9 centimeters divided by 109 is approximately 1.2752 millimeters.
You realise that Earth's diameter is 12,742. Okay? Next one up. If the sun had a diameter of 1.39 meters, so we're looking at this big, right, 1.39 meters. The distance in between the sun and Earth would be 150 meters, right? We just got to multiply that by 108. We divide the sun's diameter by 109 and it gives us Earth diameter, 1.27 centimeters. So now Earth, that's it there, 1.27 centimeters, right? It's to scale, but not with the rest of it, obviously. So if you were on this planet Earth and you had 150 meters between you and a sun that had a diameter of 1.39 meters, would you see it? Of course you'd see it. That's a running track, 100 meters plus 50, all right? 1 meter 39, of course you're going to see it a couple of 100 meters down the road, right? Thing is, this is how we move up until we get to 1,390,000 kilometers. Everything is moving up in proportion, times 10 times 10 times 10, times 10 times 10 times 10. There's never going to be a time where the distance between us and the sun runs away and the sun's size stays the same. It gets smaller. No, it moves up together in proportion. It would always be the same ratio, right? The sun, 13.9 meters, a 4-story building. The distance in between us and the sun is 1.5 k's. Earth, and that one is to scale here, is 12.7 centimeters. Now, would you see a sun that was 4 stories in diameter, right? 1.5 k's away? Of course you would. It's a no-brainer. That's how it keeps moving up. If we had a sun that's 139 meters, times 10, always times 10. All of a sudden, the sun is 139 meters in diameter. That's the running track and a bit more, 100 meters and another 39 on top. The distance in between Earth and the sun is 15 kilometers. Earth is 1.27 meters, so now Earth is up here, right? 15 Ks, a sun 139 meters, of course you'd see it. How long would it take for the light to get from there to there? Right? Moving up, 1.39 kilometers for the sun's diameter. 150 kilometers in between the sun and Earth, which now has a diameter of 12.7 meters, right? So now, Earth is just under a 4-story building. Well, it could be a 4-story at 3 meters each floor. 4-story building, that's Earth's diameter, 150 kilometers away. And we're looking for a sun that has a diameter of 1.39 kilometers. Remember the mirror. A mirror with a diameter of 12 centimeters will reflect sunlight like the flash, safety, emergency rescue, 160 kilometers, 100 miles. That is a mirror that size. Our sun is 1.39 kilometers in diameter. Do we see it? Don't be silly. Of course we see it. Next one up. Times 10, remember? We've got a sun with a diameter of 13.9 kilometers. The distance between Earth and the sun is now 1,500 kilometers. The diameter of Earth is 127 meters. Do we see a 13.9 kilometer sun in diameter 1,500 kilometers away? Of course we do. That's like not even the diameter of the length of Australia, is it? 1,500 Ks. A sun 13.9 kilometers? Yes, it's blinding us exactly the same as the one does up here. Let's jump 139 kilometers. The sun has a diameter of 139 Ks. The distance in between the sun and Earth is 15,000 kilometers. Easy comparison. Our diameter is 12,742. The distance between the sun and Earth is just over, what's that? 2,258 kilometers over, right? The distance between us. We are 1.27 kilometers in diameter, right? How are we not going to see a sun that has a diameter of 139 kilometers just over our diameter away from us? Of course we see it. It's going to be monstrous in the sky. Same ratio as it is now. Next one up. 1,390 kilometers. A sun with a diameter of 1,390 Ks. The distance between us is 150,000 kilometers. Earth's diameter now would be 12.7 kilometers. What do we have for comparisons? That's roughly is a little bit bigger than Jupiter's diameter, right? Jupiter's what, 138,000 something, right? The sun has a diameter of 1,390 kilometers. Of course we're going to see it because it's the exact same ratio as all of the others. Earth 12.7, and now comes the beauty. Instead of jumping from 1,390 times 10 to 13,900 kilometers, what is in between these numbers? La Luna, the moon. And this is a beauty. If the moon were the sun, right, at a diameter of 3,476 kilometers, Alexa, what is 3,476 kilometers multiplied by 100? Alexa, what is 3,476 kilometers multiplied by what?
3,400 is a number.
Alexa,
3,000.
what's 3,476 multiplied by 100?
3,470
This
is a
is on
number.
purpose.
3,400.
Alexa, this is on purpose. Alexa, what is 3,476 multiplied by 108?
3,476 times 100 is 347,600.
Alexa, what is 3,476 multiplied by 108?
3,476 times 108 is 375,408.
Cannot tell me, right, that she was not trying to mess me up. She, honestly, listening, I guarantee you, arseholes, right? If the moon had a diameter of 3,476 kilometers, the distance between us remains the same. The average distance between us and the moon is 384,000 kilometers. There are times when the moon is closer than this in its perigee. Alexa, what is the moon's perigee distance from us?
From richnellonline.de. Examples from astronomy. The moon has a size of approximately 3,500 kilometers, G, and a distance of 400,000 kilometers, R.
Alexa, go back to sleep. The distance, the average distance between us and the moon is not too far away from that. We would have a diameter of 31.8 kilometers. Now, if the moon were the sun, as it is with a diameter of 3,476 kilometers, the distance between the moon, the sun, and us wouldn't change. It would remain as it is, but we shrink to 31.8 kilometers. Now, where do you see, up until now, an 8 minutes and 20-second trip for the sun's light to planet Earth? It's always easily visible, the same as it was when this was 1.39 centimeters and it was 1.5 meters away. It's going up in proportion. Try and wriggle out of it. You cannot, right? That is the dancer. That just fell out of a tree like a sweet fruit. If the moon were the sun, the distance from us to it would remain the same. We would shrink to 31.8 kilometers. How would we go seeing the sunlight? We know, we see it when it's a full moon. There you have it. Bang. And then we go from 1,390, we just did the moon, now we're at 13,900 kilometers. That is the sun's diameter. There is 1.5 million kilometers between us and the sun, and we have a diameter of 127 kilometers. The same ratio, right? Nothing has changed. But the whole time this increase has been happening, nothing would have changed. It would have looked the same for us all the time because everything is going up together in proportion. One more, times 10, 13,900, sun diameter of 139,000 kilometers, Jupiter's diameter. There's 15 million kilometers in between the sun and an Earth that has a diameter of 1,270 kilometers. Do we see the sun? Of course we see the sun. Don't we? 50 million kilometers. That is got a diameter the same as Jupiter. 50 million kilometers. What's that? Well, we've got those 50 million kilometers. The moon's distance is 384 times 10 is 3.8 million times 20 is 7.6 times 40 times 40. The distance to the moon multiplied by 40, roughly. Would we see Jupiter? Would we see the sun with a diameter of 139,000? Of course we would. The same ratio as all of the others. And then we jump to us now, times 10. A sun with a diameter of 1,390,000 kilometers. The distance between us is 150 million kilometers. Our diameter is 12,742. Everything has gone up the same ratio. Everything has gone up by the same ratio. Always going to look like the sun is 13.9 centimeters in diameter, and this is it here. That's 13.9 centimeters. The distance with that diameter is 15 meters. So vroom, vroom, and a few meters down there on the fence line. And planet Earth will have a diameter of 1.27 millimeters. Can you see the sun? Of course you can. Why does it start to take 8 minutes and 20 seconds? Where does that start? There is no logical reason. It's impossible. From a distance of 1.5 meters to just 150 million kilometers, that the sun's light is going to take 8 minutes and 20 seconds. It is not 299,792 kilometers per second. It's absolute. It's illogical to think that anything takes 4.6 seconds to radiate light the distance of its diameter, because all of these, that's what they say. This scale, it's going to take 8 minutes and 20 seconds for that light to reach there. It's to scale. The same as this one, it's to scale, right? No, it does not. It's ridiculous. That, for me, was a perler. Question number 3 is, those two telescopes that we're talking about, the one that's right up, jammed up, right up to the sun, who can actually see and feel the filaments of the sun in front of him. If the sun suddenly turns on again, is it going to take 8 minutes and 20 seconds for that person with that telescope zoomed right where it was when the sun disappeared? Is it going to take 8 minutes and 20 seconds for him to see that sun when it switches back on? That's the question. It's illogical. It's ridiculous. Have a great weekend, peeps.